All right, greetings. My name is Chinedu, and in this video, I'll be analyzing this board. This is an electronic board for an inverter, okay? A 1.5 kVA, 24 volts inverter. I will take some time to explain the various parts you have in this board, so that for those of you who may have, the interest to grow your knowledge in inverter maintenance and repairs, okay, this video would also help you. And for those who are already doing that, I believe it could still help to furnish your knowledge already acquired. So here I will begin with this part of the board. All right, this is the control board for this entire board here. You can see this one vertically inserted here. This component you can see here is a surface mount device. Okay, you can see it there. That's the microcontroller. That's where your program is embedded, okay, that controls the entire functionality of this board, and then the inverter as a whole. Now when you turn the back of this board, you will see two SMD means surface mount devices, okay? So SMD ICs, they're actually comparators. Sorry, the image is not that clear, but these are comparators. You can have your LM358, LM393, as the case may be. Now what these comparators do, they compare voltage levels. Designers normally use this to monitor voltage levels, whether to set up your threshold for low battery or overload conditions. So whenever you find out that your inverter is indicating a low battery error, even though your battery appears to be fully charged, you may want to take a look at these comparators here. Now I want to go on to this to explain the purpose of these two boards, identical boards you can see here. Now these are called MOSFET driver boards. All right, they have some MOSFET driver chips embedded on them. Now the purpose of these drivers are to amplify or raise the magnitude of signal transmitted. This microcontroller generates what we call SPWM signal, all right, because this is a pure sine wave inverter. So these are the kind of signals that the microcontroller needs to generate to drive your transistors here, and then in turn be stepped up to give you your 220 or 110 volts output as desired, depending on your region. Now if these boards are damaged, you may notice that your inverter may be indicating a short circuit error, even though you test your MOSFETs and they appear to be okay. You may want to check these boards, because if they are bad, they will actually create a short circuit along the signal line from the microcontroller. Okay, so take note of that. Now these are your MOSFETs. In my previous videos I've shown you how to test a MOSFET. I may still have to do that. These are capacitors for for snubbers. I will explain snubber networks in some of my later videos. Okay, now normally these are the heat sink, which serve as a they are heat conducting materials that help emit heat to the atmosphere. Right, now this is the high side, where the positive terminal is normally connected to, while this is referred to the low side, close to the ground potential. All right, now these two these 2 points here, where your transformer primary windings are connected, so that the voltage here can be stepped up to your desired output voltage. This is a negative potential here. Okay, you can see this fuse is 40 amps into 3, which is 120 amps. Now that's basically. Now you will want to take note of this part also. This transformer you can see here is actually a mains sensing transformer, mains from the grid. It helps in detecting your mains. Okay, so if you encounter any inverter that have challenge detecting your mains inputs, you may want to begin from this section to check. Now you move on to this relay. This is your switching relay. Okay, notice that when you connect your inverter, you hear a relay click. So this is what makes that sound. Now this heatsink here is for regulators. Okay, you normally have two regulators. I've removed one because I'm still troubleshooting the board. All right, now you have two regulators here normally, which are the 7805, the 5 volts regulator, 7812, which is your 12 volts regulator. So you can just follow me and then stay tuned for more videos on how to approach some of these. These are filter capacitors along your bus, your DC bus line. Okay, your 12 volts supply. So they act as a filter along that line. Thank you.